All right, so picking up where we left off, let's go ahead and summarize everything that we've learned up to this point. So we're going to summarize everything that we've done for the variation of parameters. Okay, so to summarize, we consider the differential equation the differential equation is going to be y double prime plus q of t times y prime plus r of t times y equals g of t. Okay, and we're going to assume that y sub 1 of t and y sub 2 of t, okay, are a fundamental set of solutions okay, for y double prime plus q of t, okay, times y prime plus r of t times y equals 0. Okay, so we're going to assume that y sub 1 of t and y sub 2 of t are a fundamental set of solutions for this equation. Then, okay, a particular solution to the non-homogeneous differential equation okay, is capital Y, capital P of t equals negative y1 integral y2 g of t, okay, divided by the Wronskian of y1, y2 with respect to t, plus y2 integral y1 g of t divided by the Wronskian of y1, y2, again with respect to t. Okay, so this is a very important summarization. I would take a moment to really write this page out in detail. This will be very important. Now, depending on the person and the problem as well, some will find the formula easier to memorize and use, and some of you will find the process used to get the formula easier. Both can be used complementarily. Okay, and the examples in this section will be done using the formula just to expedite things. Okay, so now before proceeding, with a couple examples, I need to first address a couple of issues involving the constants of integration that will arise out of the integrals. Okay, so let's go to a new page and discuss this. All right, so first of all, putting in the constants of integration will give us the following. So let's write our expression, y capital P of t. This is taken directly out of the formula that we saw before. And this is going to equal negative y1 times the integral y2 g of t, okay, divided by the Wronskian, y1, y2 dt, and then we're going to add a constant of integration. We'll call it c, okay, plus y2 multiplied by the integral y1 g of t divided by the Wronskian, and this is going to be of y1, y2, okay, dt, and we'll add another constant of integration. I will call it k in this situation. And this is all going to equal the following. We get negative y1 times the integral y2 g of t, all divided by the Wronskian of y1, y2 dt, okay, plus y2 times the integral of y1 g of t divided by the Wronskian of y1, y2 dt. And you're wondering what happened to the constants of integration. Well, they get added here on the tail end, and that's going to be negative c times y1, so y1, plus k times y2. Okay? So let's explain this. The final quantity in the parentheses, this quantity, is nothing more than the complementary solution with C1, okay, being equal to negative C, and C2 being equal to K. Can you see that? And we know that if we plug this into the differential equation, it will simply simplify out to 0 since it is the solution to the homogeneous differential equation. In other words, these terms add nothing to our particular solution, and so we will go ahead and assume the following, that C equals 0 and K equals 0 in all of our examples. Okay. One final note, though, before we proceed with examples, do not worry about which of your two solutions and the complementary solution is y sub 1 of t and which one is y sub 2 of t. The reason? It doesn't matter. And you will get the same answer no matter which one you choose to be y sub 1 of t and which one you choose to be y sub 2 of t. Okay, so I'm going to end the video here, and then we're going to start our first example in the next session.